Just going to give you a quick update on the hives. I'm just heading over to do a bit of IR thermography. I'll take some pictures, internal pictures of the cluster. You can see my snowshoe track. I think right over there. I think this little hump there, that's my wellhead. So there's still close to 3 feet of snow here. It's actually a fairly warm day. It's -6 today. Probably going to go up to near 0 later today. But we've been spoiled this week. I think the coldest has been -15 one morning, and last week we did have -30 something, but it was just for a couple of mornings. But since then it's been much warmer. Hopefully it sticks because it's a lot less stressful on the bees. Cheers. I'll put some info in the show notes, but I guess tomorrow 7 p.m. Mountain Central Time, or Mountain Standard Time, I'll be doing a dry run of my presentation that I'm currently preparing for the Chester County Conference in about a week and a half. So it's going to be more of an open discussion because I just want to test the material out and get some feedback. Because I tend to go overboard with my presentations, so I just want to fine-tune it. So that'll be tomorrow at 7 p.m. My time, so Mountain Time. I'll put some information in the show notes of the video. There's the little contraption I made. So that's a door shim, or like a window and door jamb, door framing shim, with I think it's a $10 lightning cable from Amazon, so I can extend the camera inside the colony. I got a little Ziploc bag there on the IR camera, and then I take a picture upwards, so I'll see what it looks like. So my goal is to look at you can see I cleaned up some dead bees. There's not much, but you can see how the plywood provides the bees a landing space if we do get some sun. And so this middle one right here, that's the one with all the bee mortality. Underneath the board here, lots of dead bees. So I am sending some samples to the University of Florida. So I got myself some lab grade ethanol so I could send some samples so they can keep the DNA and do some checks. So hopefully I send those samples out today. But yeah, let's do some IR checking. Yeah, just before we go on to the IR camera, so you can see on the right hand side these temperatures here. That's pretty much around 10 to 11 is when I did the IR camera, and you'll notice that it's pretty flat line. I think the last time we had super cold was out over here, so this is just a few days of data. But anyways, you can see that it's pretty flat. These bees aren't very stressed out. And once you look at the R and you look at the cluster from below, you'll notice that the temperatures actually resemble the top almost. So you can see, and I did a almost side-to-side scan just to see the different seams of the different frames, just to get an idea of how big the cluster is. And you'll notice too that the bees are almost to the bottom, just above the slatted rack. So yeah, here are some seams. So this is actually looking upwards into the cluster, and the pointer is a surface temperature. And you can notice that the average temperature is anywhere from 12 to, I'd say, 14 degrees on the outer edge of those bees, and you just notice the heater bee peeking out there. The darker the color, the cooler it is. The whiter the color, the warmer it is. So the really, really warm is actually around 20 degrees Celsius. And what I did was I actually scanned from right to left to get an idea of how big this cluster is. And let's say we're March 1st right now. And pretty much the cluster is The outer edge is open, so there's no bees, and I think the temperature was around 2 to 4 or 5 degrees. The other thing you'll notice, the bee's abdomen is actually pointing towards us, so downwards, which is expected, because that's basically the way the bees form the mantle is they stick their butts out opposite and they keep their heads in. Yeah, and you can see there's not much wing beating there, so there's a bit of humming just from the bees doing their thing. But right now, yeah, the temperature outside is -7 Celsius, and you can see the bees are cozy, not very active, warm, and quite spread out. So they're not that tightly compressed. And yeah, and you can see like prior I showed you the broodminder data, and the cluster this is what it looks like during normal times. And challenge with the IR camera is the damn battery of those FLIR cameras are really not very good. You get really poor life, so I get maybe 5 minutes max out of one charge. So you can see how I'm going from frame to frame. And remember, there's a slatted rack here. So the bluish, purplish type color, the darkest color, that's actually the bottom of the slatted rack. And then the pinkish color, that's probably the bottom of the frames. And you can see here it's about 20 C in the bright spot, which is about right for the center of the cluster temperature. So here are a couple of vials. I collected some dead bees from the landing board, and some super fresh ones that had freshly died are coming out of the hive. I put them in, I think it's 100% ethanol. I soaked them overnight, and then this morning I replaced the alcohol. And I'm going to go to Purelator now and ship them to the US. Hopefully they allow me to, so we can figure out this amoeba disease. Just an update on this amoeba disease. So I actually just sent off the samples to the lab in Florida. So it should be there next week, and hopefully in a couple of weeks to a month I start getting some news out of that. These are just some pictures of some my only winter, I'd say spring failures. So they usually fail at mid to late spring. I get a bunch of dead bees in front of the colony, and typically the bees, I'd say the majority, have nosema. I've been noticing a few other indicators, I guess, and that's what I want to investigate. So the healthy colonies tend to have very few dead bees out front, and the sick ones have a lot. So in this case here, so you can see that the first time I noticed these globes, I think it was 2019, I started going through, I've got baggies full of dead bees in my freezer. So I've been slowly going through to see if I can diagnose those lobes in past history. But over here you can see my winter successes over the last since 2016. So like I said, we are forage limited, so I can't have too many colonies, but you can see that the 2018, I guess, this case here, I had 3 colonies and they all died. That's the year I had honeydew honey, severe nosema, and I'm not sure if I have bees in the freezer from that year, but I'm guessing now that I probably also had that amoeba-like disease. But then since that time, I haven't really lost a colony, and I do lose the odd one, probably one per season in late May to June. And again, this is a symptom it shows: high mortality, bees full of nosema, and now it's looking like the trigger is amoeba and because it affects their osmoregulation. I'll just go down like I mentioned before. So this was my prior symptom sheet, so high mortality, high spore count. But now that I'm looking at it, there's probably a third criteria where it's high mortality, high nosema, and likely those globes are what's causing the bees to actually die. So this is that one colony this year. Again, I collect some of the fresher dead bees. You notice the nosema all over the place, and then these little globes here. And then doing a bit of research, I started dissecting some of these bees, and then trying to get a bit more contrast in the image. So again, you can see the nosema spores and these globes, big gray zones full of nosema spores. And then I started finding these clusters of these globes. And then I started finding these tubules. And these are those tubules that I don't know how to pronounce the first word there. I think I have it in the end, and I'll try to pronounce it then. But this matches some pictures I found online of this type of infection. So this is part of the bee's kidney type organ. So it's how they transfer salts and stuff from their hemolyphs and excrete it out into their feces. And it's a really critical organ for managing water, especially in winter with no cleansing flights. So again, now I'm able to dissect it out and find these tubes, and sometimes they're clean and sometimes they're infected like this one here. And these are just different pictures. And the other thing now is I've mounted with some of the stuff I use for my pollen analysis. It's like a jelly glue glycerin type thing that pretty much mounts it permanently and protects it from it rotting. So now I have reference slides I can go back and use in the future, and they're protected. So yeah, I discovered what tracheocubes are, or tubes, and yeah, it's a lot of different things. So this is what it is, Malpighian tubules. So it's basically how they pull the uric acid and put it in their waste, and it's part of the I guess their osmoregulation, water management of the bee internals. And this is just information on the amoeba disease that hopefully I'll get diagnosed, and hopefully you'll be able to get some DNA out of the samples, so then you can get your nosema and an amoeba straight from a PCR test versus having to use microscopy. So that's the hope.